Hello everybody. This is our video solution to problem 3 from Quiz 13, Spring 2023, Math 302 at Cal State Fullerton. All right, let's see what this problem has to offer. R is a commutative ring. It says if R is a commutative ring. Cool. And if X and Y are in R such that X times Y is 0, then we say that X annihilates Y, and that X is an annihilator of Y. Okay. Fine. Working in Z mod 15Z. Okay, cool. We're working mod 15. Determine whether each of the following elements is a unit or zero divisor. Okay, so looks like we're using the square bracket notation. We're not abusing notation this time. So we're going to determine whether these are units or zero divisors. And if it's a unit, we find the inverse. If it's a zero divisor, we find a non-zero annihilator. If it's a zero divisor, that means it satisfies X times Y equals 0, right? For some non-zero element. So we, definitely can find a non-zero annihilator. All right, well, let's see. So we had a rule that told us that if we are working in Z mod MZ, so M here would say be greater than 1, then we know that every element is either going to be a unit or a zero divisor. And how do we know which? Well, we would have to look at the GCD. And if the GCD of, say, some element, some integer a is 1, then we get a unit. And if the GCD is greater than 1, then we get a zero divisor. All right, so that means all we have to do is look at these representatives and ask, are they relatively prime to 15 or not? So the GCD of 6 and 15 is equal to 3, which is greater than 1, which implies that the class of 6 is a zero divisor. So now we just need to find a non-zero annihilator. And literally what I'm going to be doing here, right, is figuring out what is missing in the prime factorization of 6 in order to get up to 15. So 6 is 2 times 3. 15, let's just write this on the side, is 3 times 5. So 6 has the 3, but it doesn't have the 5. So I need to somehow get a 5, right, multiplied in there. Well, sure enough, I just multiply it by 5, right? So the class of 6 by the class of 5 is equal to the class of 30, which is equal to the class of 0, because we're, again, working modulo 15. All right, how about 7? So the GCD of 7 and 15 is 1. So this implies that the class of 7 is a unit. So now I need to find something I can multiply 7 by so that I can get 1. Well, let's see. I can be maybe a little bit just systematic about it. 7 by 1 is 7. 7 by 2 is 14. Ooh, that's so close. 7 by 2 is 14. Now think about that, though. 7 by 2 is 14, which is congruent to negative 1. Ooh, so what if instead of multiplying by 2, I multiplied by negative 2? Because that's going to give me the extra negative 1. So this would be equal to negative 14, which is congruent to 1. So I can use negative 2, or if I want to use a least positive residue, negative 2 is congruent to 13. So I can say class of 7 by the class of 13 is equal to the class of 1. So we found the inverse. All right, how about 14? So the GCD of 14 and 15 is also 1, which tells us that the class of 14 is a unit. But the class of 14, right, we know 14 is congruent to negative 1. We just saw that up here. So if I square it, I'm going to get 1. So 14 squared will be congruent to negative 1 squared, which is equal to 1. So I can actually just use 14 as its own inverse. So the class of 14 times the class of 14 is the class of 1. Okay. All right. So in both of these cases, by the way, right, like we could be writing down here, okay, 5 annihilates 6, 13 is the inverse of 7, 14 is the inverse of itself. Okay, and then finally, the GCD of 10 and 15 is equal to 5, which is greater than 1. So that tells me that the class of 10 is a zero divisor. And in this case, I know that 10 is 2 times 5, so I already have the 5, so I just need an extra 3, so I'm going to multiply 10 by 3, and hey, once again I get the class of 30, which is equal to the class of 0. So I found an annihilator, namely 3. All right, and there we go. We've found units, we found zero divisors, we found inverses, we found annihilators. We're all good here. All right, we'll see you next time.